Hello, y'all. Welcome back from spring break and welcome to Unit 6. This entire unit is about quadratics. Quadratics have a degree of 2. If you guys haven't already made pockets in your notebook, you guys can pause. I'm going to use this little section over here, make a pocket. This is Unit 6. Name of this unit is quadratics. So if you haven't paused and made pockets in your notebook, you can do that now. You can do it later after we're done with notes. Up to you all as a class. Okay, so we are starting by learning how to find a couple of the points of a quadratic. So go ahead and throw your name on here. Always forget to say that first. A quadratic is this U-shaped graph, so it can be shaped like a U this way, or it can be shaped like a U this way. The graph of a quadratic, so a polynomial with a degree of 2, x squared being its highest exponent, is called a parabola. So that is spelled P-A-R-A-B-O-L-A. So you might hear that word throughout the unit, a parabola. It can be opening up like the red graph on the right, or it can be opening down like the red graph on the left. This unit, by the end of the unit, by lesson 6.9, we are going to be able to graph an entire quadratic. But that's a lot of things all in one. We have all of this different stuff labeled here. We are going to start by just doing piece by piece. So for today, we are going to be finding the axis of symmetry in Vertex. That's the name of today's notes. The axis of symmetry is this imaginary line that chops our graph in half right in the middle. And then our vertex is this either point that's at the bottom middle of the graph or at the top middle of the graph. Okay, so when we are given a quadratic, it's going to be given to us in standard form. So that is this form right here, ax squared plus bx plus c. A, b, and c are all numbers, and then x squared and x are our variables. The axis of symmetry is a vertical line. So vertical lines we learned back in when we did Hoivux. Vertical lines are x equals a number. So that's why this equation is an x equals equation. That vertical line that splits the parabola in half is found using the formula x equals negative b over 2a. So that is a formula we are giving you. We don't yet know enough math for me to show you why that works, so just trust us for right now. That's the formula we're giving you. Once we have done that to find our axis of symmetry, we are going to plug in that x value. So we will substitute in the x value into the equation. So we would plug it in for x into this x right here and this x right here. And then we would work out that equation and we would find a corresponding y value, and then that'll give us a point that is our vertex. Okay, so our first example here, we've got f of x equals x squared plus 8x plus 7. I'm going to go ahead and put an imaginary 1 in front of this x squared here as my coefficient. And then we have lines here for us to write down a, b, and c. So in this first problem, our a value is 1, our b value is 8, and our c value is 7. That just comes from here, a, b, and c. The first thing that we're going to do in all these problems is find our axis of symmetry, and we will always use the same formula for that. So that's the formula we're giving you. That is something to commit to memory. And so that formula is x equals negative b over 2a. So we are going to plug in our b value. So negative b would be negative 8. So the negative is part of the formula, and then my b value is 8. So I've got negative 8 over 2 times my a value is 1. And then I just work that out. I've got negative 8 on top. 2 times 1 on bottom is just 2. And then negative 8 divided by 2 is negative 4. So that means my axis of symmetry is a vertical line at x equals negative 4. From there, we can now find our vertex. For our vertex, we already know half of our answer. This is an ordered pair x comma y. We already know that the x value of our vertex is -4. If I slide back up here to the graph, to this picture, since our vertex is always on our axis of symmetry, the x value is always the same x value that our axis of symmetry is. So what I'm going to do to find the y value of my vertex is I am going to take this original equation, which was f of x equals 1x squared plus 8x plus 7. I just copied that down from right here. And I am going to plug in -4 for x. So I am finding f of -4. So we did that back in Unit 4. At the beginning of this semester, we evaluated things in function notation. I'm plugging in my -4 for x. So that's going to be 1 times -4 squared plus 8 times -4 plus 7. You do need to show your work of plugging in that x value. And then from there, just like we did back in Unit 4, you can either choose to do the work by hand, or you can choose to do the work in your calculator. So we'll do both in our notes. I'll have to get the calculator pulled up here in a second. If I were going to do this by hand, I would do -4 squared first, because order of operations, exponents happen first. So -4 squared is 16, positive 16, and then 1 times 16 is 16, plus 8 times -4. 8 times -4 is -32. And then plus 7. So then I would have 16 minus 32, which is -16. -16 plus 7 is -9. So that would give me a vertex at the ordered pair, -4, -9. Okay, let me pull up a calculator here real quick. Oh, I locked the whole screen instead. Now I have all my apps moving. I promise I know how to use an iPad, kind of. Where is my calculator app? Oh, look, there's a picture of me and my baby. Where's my calculator at? Calculator. There you go. Okay. Split view. Let's bring our notes back up. Okay, so if I wanted to throw this in the calculator, I would do 1 times -4 squared plus 8 times -4. Make sure you close your parentheses every time, plus 7. And I would get -9. So you can do it in a calculator. You can do it by hand, completely up to you. All right. So that is our first example. Let's do it again so we can see some other things that might happen. We've got 2 more examples here. Next example we've got is 2x squared minus 12x plus 16. In this problem, my a value is 2. My b value is -12, and my c value is 16. My formula to find my axis of symmetry is always the same formula. It is x equals -b over 2a. So x equals -b over 2a. That's my formula that we just are giving you. We are going to plug in our b and our a values. So the negative is part of the formula. And then my b value is -12. So I've got -12 on top. This would be the point at which I say a negative is positive, and you guys would say positive. So -12 is positive 12 on top. And then on bottom, we've got 2a. So it's going to be 2 times 2. And then 2 times 2 is 4 on bottom. So 12 divided by 4 is 3. My x value is 3. Which means I already know half of my vertex. The x value of my vertex is 3. Okay, to find the y value of my vertex, I'm going to plug in that 3 for x. So I'm going to do I'm going to take my original equation, which is f of x equals 2x squared minus 12x plus 16. You guys can rewrite it without it, or you can just rewrite it with it plugged in. You don't need to rewrite the formula or the original equation when it's right there. From there, I'm going to plug in 3. So I'm going to be finding f of 3. So that's going to be 2 times 3 squared minus 12 times 3 plus 16. And once again, I can work that out by hand, or I can put it in a calculator. If I work it out by hand, I'm going to do 3 squared first, which is 9. And then 2 times 9 is 18. Minus 12 times 3, so that's minus 36, plus 16. 18 minus 36 is negative 18, and then negative 8 plus 16 is negative 2. Okay, last problem I have here. We, once again, don't have a coefficient on that leading term, on that x squared. We do have a negative, however, so that means that there's a negative 1 here. So my a value in this problem is negative 1, my b value is 2, and my c value is negative 5. Okay, split my workspace up here. I am going to find my axis symmetry. My formula is always the same thing. X equals negative b over 2a. Plugging in my b value, that's going to be negative from the formula, and then my b value is 2. And then on the bottom of my equation, my a value is negative 1, so this is going to be 2 times negative 1. So on top, I've got negative 2. On bottom, I've got 2 times negative 1, which is also negative 2. So I've got negative 2 divided by negative 2, which is positive 1. So my axis of symmetry is that the vertical line x equals 1, and then that means the x value of my vertex is also 1. Okay, now I need to find my y value of my vertex. So I'm going to take my original equation and I'm going to leave that negative 1 there as a leading coefficient. That's going to help me when I plug things in here in a second. So negative 1 times x squared plus 2x minus 5. And then I am finding f of 1. So that means I'm plugging in 1 for x. So that's going to be negative 1 times 1 squared plus 2 times 1 minus 5. Okay, same thing, order of operations, 1 squared first, which is 1, times negative 1 is negative 1, plus 2 times 1 is just plus 2, minus 5. Negative 1 plus 2 is 1, 1 minus 5 is negative 4, so that means I've got a vertex at 1, negative 4. Once again, we didn't do it on the last one, let's go do it on this one real quick. We could throw this in a calculator. Let's split view. Bring back our problem right here. So we are plugging in negative 1 times 1 squared plus 2 times 1 minus 5. Double check, we get negative 4. Awesome. Okay, that is it for 6.1 notes. Make sure if you guys didn't make pockets already, you go get those pockets made and get these notes glued in. That is all. Thank you very much.